In sequence.
What does?
When they're moving at the
Let's
same
start
time.
with motion. What does motion mean?
A change in their position in space.
Yes. What else? Movement. So something moves from one place to another place. How about harmonic motion?
At the same time.
Yeah, when multiple
At the
things
same time?
move
What does mean at the same
Or
time?
like in balance? I don't know.
Moving together.
One together.
One object's movement determines the other.
Yes. What else?
They work together.
They work together.
They're connected in some way. I don't know.
What else? What does harmonic motion mean?
It's kind of like harmonizing when singing. They go at the same time and same intervals.
It was like this, right? This is harmonic motion. So when I release this ball, moves and come back, back and forth, back and forth. So it is called simple harmonic motion. So again, we start from here. When I release it, so that ball moves over there and then comes back, moves over there and then comes back. And what do you observe on this demonstration? What do you observe? Kinetic energy. Yes,
It's not
energy.
losing any height.
You may write kinetic energy.
It's
You
not
observe
It's not
kinetic energy.
Yeah, it's potential. Potential stone.
What else? What do you observe?
Potential energy.
Potential energy. Why?
Because as it goes up, it starts losing kinetic energy and then gaining potential energy. And
Because of the height. Right. What else? What else?
Air friction.
Air friction. That is important one. Air friction. How did you decide there's air friction?
Because it's
Because it's slowing down, so the motion dies. So when you start from here, and then slowing down, and slowing down. What else? What else? What do you observe? Yes?
tension force.
Tension force. Why?
Because the ball's hanging from a string.
So there's string, so there's tension force. We observe tension force.
gravity.
What else? Gravity.
Gravity.
So gravity affects always. What else? What else? Another idea? Diana, what do you observe? Yes.
Motion.
Motion. So it is harmonic motion. What else?
What do we observe?
Mhm. I think that's all right. And how about measurable stuff?
Weight.
Wait.
So we can measure that ball's weight,
Yes.
We can also measure its mass.
And its height.
and we may measure
We can also
balls,
measure
mass.
tension force.
tension force, we may calculate
We find
And
force using
heat, tensional force. What else? What else?
Angular velocity.
Velocity, we may
Nice.
measure angular velocity.
We can measure
What else?
linear velocity.
What?
We can measure tangential velocity.
Tangential velocity.
Yeah. See.
What else? Yes.
Length of arc.
Hmm?
Length of arc.
Length,
Arc length. Arc length.
arc, length. What else? What else? What do you measure?
I'm just messing with that.
We can measure the length of
The string.
string. Length of string.
The diameter of the ball, but I don't know what we'd use that for.
So we may
Do it.
measure radius
Oh yeah, the radius there.
of the wall, or
We can find the volume.
we may measure torque.
Oh, well, I thought we just found it. It's too late.
Alright, is that all? What else?
And measured it.
I think that's all. How about variables?
Fancy tea.
Variables, like independent or dependent variables.
Nothing's like changing.
Yeah.
Height?
There's
What?
Time.
arc length.
Okay.
What else?
Arc length. That's a variable because the arc length keeps getting shorter over
The length of the string.
Oh my god.
Right? What else?
Arc length.
What else? Arc length. Another one. What else?
Yes.
What else?
Twice.
3 times.
Three. Oh.
Oh my gosh.
Yes.
Angular velocity.
Angular velocity. So we can measure angular velocity. What else? And that can be variable. What else?
Mass and starting position.
So let's talk about mass. If I change the mass like this, so can you guess what will happen when I change the mass?
I feel like it will swing slower.
Yeah.
Slower
Yes.
or faster or same speed,
Slower.
slower. Why?
Because it doesn't have as great of a mass, so its kinetic energy will be less.
Then energy will be less. What else?
As well as
Another
its
idea?
energy.
Any other idea?
It won't, like, it'll keep swinging higher for longer because it has less surface area to have air friction.
So that stuff swings more time, takes more time, huh?
Yeah.
And what else?
More inertia.
More
Inertia.
inertia. Which one has more inertia? Small one or big one?
Big one.
Big ball.
Why?
Because the
Big ball.
mass. It
Because
takes
of-
more time to stop.
Mass. Alright, what else? So let's see. Let's see. When I release these two stuff from the same height,
They're swinging at the same speed Alex goes. So.
what's going on? Same speed, different
It's starting
speed.
to get unsynchronized.
Like same speed, right?
It is the same
So
speed.
when I change the mass, so the harmonic motion doesn't
I was
change.
wrong.
The velocity doesn't
It has less
change.
kinetic
So let's
energy
see one more time. With same speed. So when we change the mass, our velocity or our harmonic motion doesn't change. And how about the length? If I change the length, so mass is not important for simple harmonic motions. How about the length?
Can I go into the string?
If I change the length of string,
It changes the arc length.
what will happen about like speed, about time, or about the motion?
It's
Speed. Which one moves faster? Smaller one. Why?
it has less distance to cover.
And then what else?
Tiny.
Their masses are same.
What's
So-
the length of the arc?
Arc
The length of the string.
The length of the string. So that is so important. So first thing is
Everything I know is a lie.
first thing is the length. So the length is so important for simple harmonic motion. Let's see one more time. So when we short the length, so simple harmonic motion will be faster, or the ball moves faster.
I helped.
Alright, so and then what else? So talk about kinetic energy with the small length and the long length. So which one has more kinetic energy?
Small length.
Small length. Why? Because it moves faster. How about potential energy?
The
Uh,
long
the
one.
Their
small
potential
length.
energy.
The small length.
The small one has
more
more
potential energy.
potential energy. Why?
Oh,
Because it's higher up.
Because it is higher than this stuff. And how about the air friction?
They have the same.
They have the same amount of air friction because they have the same mass and
same
they are in the
surface
same
area.
location. How about when I change the location and other stuff? Gravity.
What if you do it in space?
Let's say we take these two of them to the moon instead of Earth. Let's say we take this stuff and then we are doing same motion on the moon. What will happen?
It'll just go
Nothing will
slower.
change.
Slower or faster?
Oh, well, the.
Wait. Are we doing it in a vacuum on the moon?
No.
Oh, okay, then
Just
yeah,
regular.
it'll go slower.
So we took this stuff to the moon and we see the motion on the moon instead of Earth. What will happen? Slower or faster?
Slower.
Slower. Why?
Because its potential energy will be less due to the fact that the gravitational acceleration will be less.
Will
Because
be
gravity on
less.
the
So
moon's like
the moon has
3 meters per second squared. So
the Earth gravity is
9.8.
9.8 meter per second square, and when we go to the moon, that gravity will be
3.4.
what?
It's like it's in the 3 meters per second squared.
I think it will be 1.6
I don't
meters
know.
per second square.
I don't
And what will happen? Of course, this stuff will move faster or slower.
Slower.
Slower. So we have two important stuff in harmonic motion. So first one is gravity. Gravity is so important, and then second one is the length. So when you change the length, so the torque will be changed, the angular velocity will be changed, tangential velocity will be changed. And how about the radius? The radius?
Radius of the ball?
Yes.
Oh.
So when you compare these two balls.
I don't think it matters.
Alright, how about the radius?
The radius is less.
Radius. When I change the radius like these two balls, is it affected by the radius?
Wouldn't it affect the surface air friction? Like the.
It affects air friction slightly.
No idea, no other idea? So when I change the radius, is it affected by the radius? Yes.
No. Well, it is there and there.
There and there. Let's see.
Yeah, but I feel like that's more of an issue between differences of mass. than
Alright,
it is-
different or same?
The small radius and the larger radius.
Different or same motions? The same motion. So the radius is not important for simple harmonic motion. So we have two important stuff. First one is the length. What else? The gravity. So two